Hello everyone, I'm Qingwen from KTH Sweden. Today I'm excited to share our NeurIPS' 2025 spotlight paper, DeltaFlow, Efficient Multi-Frame SimFlow Estimation Method. It's also the winner of CPR workshop on autonomous driving, Argovos-2 SimFlow Challenge this year. The motivation behind DeltaFlow is quite simple. When we estimate SimFlow, each new frame can benefit a lot from history. Historical frames give us a strong motion clue. For example, even all points disappeared in the next frame, you can still guess their motion based on how they moved before. In other words, multi-frame input capture temporal continuity, which is crucial in real-world LiDAR stream sequence. But the question is how to fit multiple frames into a backbone. Existing methods usually go for two directions. The first one is concatenates feature along the channel dimension. This keeps the same 2D or 3D backbone but blues up feature size. Adding a temporal dimension building a 4D network is another way, powerful but heavy and expensive still. Both approaches suffer when the number of frames increased. So we ask, can we keep the temporal clue but avoid feature explosion? That's the key idea of DeltaFlow. We applied a delta scheme, focusing only on what changed and keep the feature size constant, regardless of the number of inputs. Here is how it works for each new frames after going through MLP and feature extraction from 3-dimension to high-dimension features. We compute the difference and a simple subtraction between frame pairs and then apply time decay, weighting, and then sum them up. The result is a compact delta features capture motion clues across multiple frames. We can then plug these features into any 3D backbone. Here we use sparse units, followed by a decoder head to predict SimFlow for each point. This design is lightweight and plug and plays and scale to any number of frames. This visualization shows why it works. First, the single frame features mostly capture geometry only. Then delta feature highlights the motion region. As you can see, trail-like patterns follow in moving objects. The idea is actually inspired by motion blurring in photography. Human can often infer motion direction even from a single blur frames. After refinement by the backbone, these clues can be clear and clean motion patterns. Beyond the architecture, we also improved the training loss. We find the existing method often underperform on small or rare objects, for example, pedestrian or cyclist, and sometimes predict inconsistent motion across one object. So we add two new terms, a category-based loss to handle class imbalanced and improve learning for underrepresented category, and instant consistent loss enforcing uniform motion for each object instant. Together, this helps DeltaFlow capture motion details across all object types during training. Now let's look at the result. DeltaFlow achieves total performance across 3 large-scale datasets, Argovos-2, Waymo, and NeurIPS'. On Argovos-2, it ranks at first on the public online leaderboard with 22% lower error and 2 times faster inference than the next best multi-frame method, Flow40. It's also consistently outperformed others in all datasets and all categories, especially on pedestrian and valuable road users like here. One of the biggest advantages is scalability. As we increase the number of frames, traditional 4D methods like Flow40 quickly slow down and consume a huge memory. In contrast, DeltaFlow's input stays constant, so the runtime and the memory barely grows. In practice, even with 50 frames, DeltaFlow is still 2 times faster while maintaining top accuracy. Interestingly, DeltaFlow also shows strong cross-domain generalization when trained on Waymo and tested on Argovos-2 or the other way around. It still outperforms all supervised and self-supervised baseline. This suggests that Delta scheme helped the model learn more universal motion clues that transfer well across dataset and sensors. To summarize, we propose DeltaFlow, a lightweight and scalable delta scheme for multiple frames SimFlow. We introduced category-based and instant consistent loss for better dynamic object learning. More results here can refer to our main paper. And we achieved SOTA performance with strong efficiency and generalization. Overall, DeltaFlow makes multiple SimFlow practical for real-world autonomous driving perception. Thank you for your listening. Our code and benchmark are open sourced on DeltaFlow GitHub, and you can also find all baseline and implementation dataset and evaluation script in the open SimFlow repo. Stay tuned with us about following work on self-supervised multi-frame feed-forward SimFlow estimation. Thank you.